All right, so this is just a recap. The average rate of change is the same as calculating the slope between 2 points. Okay, I want you to keep those 4 decimal places because a lot of times when you're dividing by this quantity, especially when we get really, really small numbers, right, dividing by something really, really small cuts off a lot of information. Okay, and I think we talked about the rest of that. So here's basically what we're saying. This is that picture of the door, the number of degrees versus time. And what we're talking about is, what if I zoom in a whole bunch right in this little area right here, right? If I zoom in enough, it basically becomes a straight line. And so if I calculate the slope between 2 points really close to 1, it will give a more accurate estimate, but still an estimate, of the instantaneous rate of change. Okay. All right, so I actually did it a bunch for you. Okay, so I looked at the average rates of change for these time periods right here, okay, where we're talking about very small changes in time. Okay, so 1 second to 1.01 seconds is literally a difference of 1/100th of a second. 1 second to 1.001, 1/1000th of a second, and so on and so forth. And I went and calculated the average rate, or the slope between the 2 points represented there, right? And this is what I came up with. And you can see it starts off being like 30.23, then 30.64, then 30.68. The 30 part is staying really consistent, so I'm pretty confident in the 30 part. You can see here, right, the first digit changes from a 2 to a 6, but then it stays a 6 the rest of the time, so the 0.6 seems like it's probably accurate. The next decimal place goes from a 3 to a 4 to an 8 to an 8 to an 8, so I think that it seems like the number that the average rate of change is getting closer and closer to is approximately 30.68 degrees per second. Okay, this limiting number, or the number that it's getting closer and closer to, right, is 30.68. Okay, there's still some variation in that third number. If I really needed to lock in a third digit, I would have to do some more time periods here that were even smaller. Okay, so this again represents the rate of change at 1 second. It is not the exact answer. Remember, that is still an estimate.